Let's look at an example of where we're looking at a one-sided limit, where we're specifically looking at coming in from a certain direction and using the limit laws at the same time. So if we look at this function, the square root of x minus 3, it's the graph of the square root of x, but it's shifted to the right 3 units. So the graph is only defined over the interval from 3 to infinity. This is the domain. So the graph doesn't exist to the left of 3. Since the function is not defined to the left of 3, we can't apply the limit laws to compute the limit as x approaches 3 from the left. And so this limit does not exist. So looking at part B, we would say it doesn't exist. However, if we're looking at it coming in from the right, the values of x exist to the right of 3. So if we think about approaching 3 from the left, we're going to be getting values like 3.1, 3.01, 3.001. We're getting numbers that are bigger than 3, but getting closer and closer to 3, and those values exist. So in this case, we can use direct substitution in the limit laws. So all I would do is plug in 3, and I can see that the limit for the y value that's approaching 0. So as I come in from the right, I'm approaching the value of y is 0. It's getting closer and closer to 0. So when you're dealing with functions that do not have the domain of all real numbers, and you're thinking about the limit coming in from different directions, you have to be careful and make sure that you're coming in from a direction where those points exist on the graph.